Hello, everyone. Welcome to Chaos Carnival. In this late night talk, we have Nik Jain, who is the director of solution engineering from Dynatrace, and he's currently the head of the team of senior solution consultant in the region. Nik is more than just a BizOps and DevOps consulting experience for leading the global software vendors in AIOOps and DevOps category. In addition, Nik has featured as a speaker at world-leading conferences like reInvent, KubeCon, DevOps Days, Talks, Perform, and more. So without any further delay, I'll just invite Nik on stage. Just a second. Yes. Hello, Nik.
Hey, Sarita. How's it going?
Hi. Yeah, it's definitely fine. And I hope our audiences are desperately waiting for your talk. So yeah, let's have it.
I think that was a very generous intro, but I'm still a developer at heart. And firstly, I want to take the opportunity to say good morning and good afternoon to everyone who are willing to spend their time with me. The session is going to run for half an hour. I'll briefly share my screen, but I want to get your attention towards the poll questions. If you scoot over to the poll questions, I would love for you to submit your responses. And then later on in the presentation, I will share with you the outcomes of those polls. So let's get started. Hopefully you've got coffee or some nice drink next to you. I know you're joining from different parts of the world. So I'm pretty excited to take you on this DevSecOps journey. So I'm going to share my screen and not sure if someone is able to give me a heads up if my screen is displaying okay. All right. So.
Yes, Nik, it's visible.
Oh, thanks for that. So I think you'll find 3 polls in the poll section. The first one is on DevSecOps vision. The second one is surrounding DevOps and automation maturity. And then the third one is surrounding chaos and real-time vulnerability scanning. Now, if you just spend a few seconds while you're following the conversation today, in terms of submitting your responses, I think it's going to help all of you to understand, how different companies and different teams sit in terms of their DevSecOps vision, maturity, and some of the more advanced use cases that has been a limelight of the conference today. So without further ado, I want to uncover the agenda. So the first thing I want to shed a light on is talk about the challenges that many enterprises face that specifically stops them from reaping the benefits of DevSecOps. The second thing I want to share with you is once we address and accept those challenges, I want to review together with you the simple, automated, and repeatable model in terms of standing up DevSecOps. The third thing I want to touch on is the proposed approach and the benefits associated with those approaches. And lastly, hopefully we'll have some time to see everything working in action. And, that's what I typically like to do, give you some view into how it works in action, as opposed to a lot of theoretical presentation material. I generally don't even do PowerPoints, but, I'm getting used to firstly setting the scene and then diving into how things work in action. So you have all the background on some of the critical fundamental building blocks of DevSecOps. Q&A, we'll try to reserve some time towards the end, but feel free to park all your questions as they appear in your heads through the session, and we'll review them, we'll respond to them in one go towards the end. So now that we've gone through the agenda, I'm not sure how many of you can identify with this situation. That situation where you've forgotten something critical and somebody within your team tells you, oh, if you forgot it, it's not that important. And then you let that satisfy you in terms of you being prepared. And allow me to caution you, it doesn't just happen with performance testing. It often happens with a lot of other things, like you've forgotten your chaos tests. You have forgotten, or rather, I should say, we have forgotten observability as code, our day two readiness checklist. Sometimes we forget our auto remediation runbooks, and this could be to self-heal an application-led problem in production, or an infrastructure service-led problem in production. And then the list goes on and on. If you look into your own situations, I'm sure you'd be able to come up with a list longer than my shopping receipt. Now, my backstory is relevant, and Sarita introduced me, but in the last 15 years, since my developer days, the only thing that has changed is back when I was a developer, I used to get some real shivers right before or right on the day of go live. And now, because I know better, go lives are not that dreadful. I'm able to navigate them a lot more elegantly. And hopefully, some of you who have joined the session, you've got a similar experience to share, and yell out if you can identify with that sentiment there. Now, there's an interesting graphic here to explain, how you transition from DevOps. And there's a really angry penguin here as Jesus or, the Almighty introduces DevSecOps. But the graphic I've used to introduce DevSecOps is the doubts and fears and apprehensions a lot of people have surrounding DevSecOps. So let's firstly accept together as a team that DevSecOps journey is not easy. Think about the journey you took in order to achieve your DevOps maturity. So the transition hopefully is not going to be as painful as migrating from the pre-DevOps world to the DevOps world. Hopefully that journey is going to be easier, but I know this for sure. It's not a smooth ride, and you have to be in it to see the final stages and the benefits of the journey. Some of the other more specific challenges that are process related are manual application security testing in early stages, development cycle are still a common way of solving application security, and that's not peppered across each and every stage of the software delivery cycle. I hope some of you got the time to read the Unicorn Project by Gene Kim. I'm not associated with the publisher or with Gene Kim, but there is this fictional company called Unlimited Parts in that book. And I can really associate with how the cross-cutting functions can affect the dev tool chain. And security testing tools are still not a cross-cutting function in a lot of organizations. And same with chaos engineering, same with observability. And that's one of the other challenge that we have to solve before reaping the benefits of a DevSecOps strategy. And there are some other things in there which we'll review as we go forward with the presentation. Now, I've put together this little steps to the DevSecOps goodness. And the first step there starts with the developer. And I look at these as little conveyor belt checkpoint mechanism. So the first gate is dev optimization. The second gate is quality gate. The third gate is your application security and chaos gate. Although in an ideal situation, I would like to have the AppSec gate as a continuous and a constant process at each and every stage of SDLC. And then lastly, you have your site reliability gate or SLO-driven operations gate. So what happens is you've got an app or you've got a collection of microservices or modern 12-tier, N-tier architecture-based application. If that application is able to make through the dev gate, that first cut version can either go forward towards quality gate or it will either go backward. And there are certain criteria that will apply to the application that we'll review a little bit later in this presentation. So notice at each and every checkpoint, you again have a go forward mechanism or a rollback mechanism for that application if that application is able to make through to the next stage of that DevSecOps strategy or workflow, if you will. Now, the other key challenge is for you to build a common data stack, a common data platform for DevSecOps. And it's completely possible. I will share with you some recipes that I have seen. And I want to clarify the objective behind my talk isn't to promote a specific tool. Use whatever tool you like as long as you are able to reap the benefits or more specifically, the business and technical benefits that I'll be introducing in this presentation. So now I think it's vital to answer the why aspects. If you're a Simon Sinek fan and you like to get to the why before you get into the what's and the hows, why quality gate checkpoint is important. I think the dev optimization stage or gate is obvious, which is why I've skipped it from the list. But the quality gate is really needed to automatically create a gatekeeping mechanism for providing negative and positive feedback to the developers who have just triggered the DevOps pipeline. Or if you have GitOps, you still want the developer to know as soon as a new feature predictively threatens the production SLOs and the uptime of those critical workloads. And the second important part, why think about a quality gate, is quality gates are a scientific scoring system based on an SLO stack. So SLOs just don't belong in production. In fact, I can think of 13 or 14 use cases where SLOs can be used across the software delivery chain, and we'll review one or two such use cases today. Similarly, there is a problem with traditional security tooling or SecOps approach. And security operations or security should really be a shared responsibility. And I'm not trying to create more workload for developers or pre-production teams, but there is a continuous process you can introduce in your production environment, which can be categorized as application monitoring and protection as per Gartner, but it shouldn't really be an afterthought or a point-in-time exercise because vulnerabilities can be introduced at any point in your software delivery chain. So that's the core why for AppSec, and there are other whys. The inability to answer certain questions that I'm going to identify and review with you in a short moment. Hopefully, when it comes to chaos engineering, and chaos engineering has been front and center for a lot of enterprise teams, whether you are a bank, a financial services institution, or an exciting Netflix-like idea, chaos engineering has become front and center for a lot of organizations, but the widespread adoption is yet to happen. We're yet to reach the peak of the adoption trend. And that's why I want to reiterate why chaos engineering. So for some of you, it must be obvious by this stage of the conference. It smokes out the most elusive architectural flaws, scalability, and performance problems. And that's the best feature I like about chaos engineering. But I'm a big believer in site reliability and specifically Google's recipe to site reliability. So I like that it helps to reinforce site reliability goals and also helps to enhance business resilience, which is needed because technology really exists to support all the business services and support the business owners that make technology happen in the first place. So in my demo, I'm using a combination of tools, and I now want to introduce those tools. So I'm firstly using Captain, a CNCF sandbox project, as my quality gate checkpoint. I'm using Dynatrace application security, which is a part of the observability agent that does full stack monitoring. So the same agent also is able to execute real-time and continuous 24/7 vulnerability detection. And thirdly, I'm using Chaos Litmus as my chaos engineering tool. Litmus Chaos. So again, the objective is not to impress upon you that you have to use these specific combination of tools in order to enable that common data platform. Assess your current tools, look at your current tools, and start thinking about what else can be introduced in the mix in order to solve these inherent problems. So this time around, on that same workflow diagram, I simply want to introduce the criteria for each and every gatekeeping mechanism. So the first criteria for developers, which is nothing new, it's been around for decades. 15 years ago, when I was a developer, we were still executing on this criteria, which is make sure that whatever release I send into higher level environments is bug-free. The second gatekeeping criteria for a quality gate is SLO-based, and the criteria there is out of 100, my new feature or application is able to meet a certain number of score in order to promote further towards production. The criteria for AppSec and Chaos Gate is fairly straightforward too. So from an AppSec perspective, for any new feature, there are no vulnerabilities. And second, you've executed your network black hole tests. You have shut down a certain Kubernetes node and tested how your system reacts as a whole to those hard incidents, and also deleted certain pods to see if the pods recreate. So you've actually tested a wide variety of experiments that could challenge the resiliency of your business and your services in production, and you have preempted those, and the results are A-OK. For the production environments, you want to make sure the error budget is not negative or less than 0. And if you arrive at a juncture where your production SLOs for your critical applications have gone negative or 0, you have stopped the feature release train, and you can continue them as soon as your error budget has been replenished. So hopefully you agree with most of what I've shared with you. Now, before we dive into the demo, I want to show you some screens that basically give you a view into how life could look like with the advent of DevSecOps. So here, I've got a heat map that assesses my release on multiple SLO criteria. And the key questions that are answered here is there a way to assess the quality of my release? Is there a way to enable an early warning system which showcases or sheds a light on issues that threaten my error budget and availability of my critical service? And from an application security perspective, there are 3 questions to answer. Are we vulnerable? Is there a log4j or log4shell like situation about to happen in my production environment? At what scale? Which containers, which clusters, which databases, which hosts could be exploited via those CVEs? And then where do I start in terms of prioritization? And notice one small thing: all of these questions are unanswered by traditional AppSec tooling, which basically answers if your code base is vulnerable and not in runtime environments. Traditional tooling doesn't really have 24/7 vulnerability monitoring in production, exactly like observability, and they are unable to give you automatic prioritization of a variety of vulnerability-related problems. So moving on, from a chaos engineering perspective, the key questions to answer before you even think about incorporating any of these use cases is your architecture resilient? Do you have the data to identify where there are weaknesses in your architecture? Do you understand your system behavior from a non-functional failure perspective? And are the SREs or operators prepared to face a SEV1 incident? Do they have the recipe books, the post-mortem mechanisms? Are your SRE tooling and your chaos engineering tooling aligned for a complex 12-tier or microservices architecture? So I'm not going to make you drink from a fire hose. So let's see some of this in action. Again, these are the combination of tools that I'll be using for my demo. Dynatrace Observability Platform, Captain, which is a sandbox project by Dynatrace, Litmus Chaos, and GCP for hosting a majority of my services. I'll also take a pause and quickly check if there are questions. I can see some questions here. We'll briefly get to them as soon as we have gone through some level of demo. And hopefully what I've shared up until now is insightful. So please provide your feedback in the chat section. Now, firstly, let's talk about the developer use case. So back when I was a developer, and even a few years ago, the dev tooling wasn't as sophisticated as what's possible today. So in front of you, you've got Dynatrace UI with custom multidimensional analysis screen showing in front of you. I'm not going to focus on everything that is helpful for a developer to execute early optimization, but the common use cases would be profiling and optimization, distributed traces. You analyze distributed traces. You do slow SQL optimization. Even look at how your services chew up infrastructure resourcing in environments like Fargate, Kubernetes workloads, serverless environments, and whatever have you. So I've got a store booking service, which is a hybrid service by design. And notice here, there are 2 transactions in my dev environment that took longer than 10 seconds to process when my objective for this service was to complete within 1 second. So I can then analyze what really happened. And I've got a bunch of tools to drill into for a developer that wants to proactively optimize. And I have some of these screens open where the developer is essentially looking at a view from yesterday's version of the application and comparing it with today's version. So notice I'm comparing against a variety of golden signals, including response times, failures, CPU consumption, and load for this particular service. And I'm able to see specifically which business transactions have gone awry, they have gone slower than expected. And I'm also able to see a high-level view of which transactions are failing more than expected, or if I executed some optimizations, have failures reduced in quantity compared to yesterday's variant. And notice here, yesterday I had 2.65% failure rate, and today I have almost 5% failure rate in pre-production environments. Not good news. The other use case I want to share with you is pure paths. And this could emerge from open telemetry sources or open source sources or Dynatrace native one agent tracing. So here you have some simple filters to only look into those transactions that failed and for a certain category of response time duration. So if I drill into one such transaction that took 5 seconds to complete, I could essentially exactly look at the failures that took place. Here are some of the stack traces that show up. And apparently the Visa and MasterCard integration has failed here. I can also reconcile my log sources if logging is enabled for those traces. But what I really appreciate about this kind of view is the ability to quickly look at the highlights of my traces and only then promote this build into higher level environments. Let's say your application was able to make it to the cloud quality gatekeeping mechanism. So this is where you get a COE dashboard where you can even view your performance tests, whether they are automated or manual, whether they are executed via JMeter or any similar tool. And you can specifically see which test cases are failing and why they are failing, and then drill into the pure paths for those or the distributed traces for those test cases. But what's really exciting here is I'm looking at my Azure DevOps release train, and I have just observed a release that has failed. So this release is basically showing me that in staging environment, for some reason, a failure was received. If I drill into the logs here, I'm able to see exactly the reason why this release has failed. Apparently, the quality gate score is lower than desired. And if I then drill into that view, I'm able to see why it's lower than desired. So let me drill into that screen quickly. And as the quality gate screen is coming up, oh, I got an error. Okay, that's self-resolved. So let me show you this heat map briefly in terms of how this quality gate works. So notice every column represents your releases. On the left side, you've got your SLOs. And at the bottom, you get specific feedback on which SLOs failed in pre-production environment. So this is predicting the type of challenges this release is going to create in production in the pre-production DevOps pipeline execution. I don't think I have the time to get into each and every detail here. So I'm going to lastly show you a view into the AppSec gate as well. I wish I could get to chaos engineering use cases as well. But here, from an AppSec perspective, I firstly get the most impactful recommended fixes. And notice, no surprise, the vulnerability that I'm being told that I should take a look at is remote code execution, which is created by log4j jar files, which created a lot of hoopla within the industry in the last couple of months. And I'm able to answer all those questions as to what risk am I exposed to. I'm also getting a priority here in terms of situational score aside the standard open source CVSS score. I also see a blast radius of what can be exploited via the remote code execution vulnerability, and what's the span of all those infrastructure in terms of proper details and specific Kubernetes clusters, databases, services, and applications. And at the bottom, I see the vulnerable component and even container images that use that vulnerable component. So I'm going to stop there and go back to the Q&A, since I know I may have overblown my time. Hopefully that was insightful, and hopefully I didn't rush too much, but keen to hear from you in terms of Q&A. And Sarita, I'd love to bring you back in for any questions that need answering.
Yes, Nik, that was quite insightful. I can vouch for my audience as well. So the first question that we have is from Vishal Arora. He needed a bit of clarity, I think, in implementing chaos engineering for multi-cluster. So if you can throw some light on there.
I'm assuming multi-cluster here means multiple Kubernetes clusters. I'm not sure what you mean by multi-cluster. But chaos engineering, to me, is not confined by, at least from the tools that are available today. And chaos Litmus Chaos is a good example. Chaos Native is a good example. It covers the breadth of cloud native tooling, and you're not limited by the type of architecture or the number of clusters that you have at hand. So you should be good to go if you ask me. But feel free to reach out to me separately via LinkedIn or drop in a follow-up question.
Yes, definitely. So they will be redirected towards Slack, which you too will be joining in. And in that message thread, you can clarify your answer over there. So we have another question, like, what role has security played in your DevOps experience, and any big security issue that you have faced, which was a real brain scratcher for you?
Yeah. Oh, there are several. So, the common misunderstanding is that when you execute those point-in-time vulnerability scans on your code and you spit out a report, that separate process, which may take a couple of days or a few hours, is sufficient to future-proof your application for any vulnerabilities introduced in production environment. I think that's a passé, and it's false thinking, because a lot can happen after those code scans, which is essentially just a point-in-time exercise, and the value is mostly received in the left side of the DevOps cycle. So the real brain scratcher is when you still get Log4j type of situations in production, and you begin to wonder, why didn't I catch this in pre-production stages? And if you didn't catch it, that vulnerability has existed for a long time, but it was called out recently. The ability to have a service that tells you within 15 minutes that a certain percentage of your hosts are vulnerable, I think it's a game changer when you come across those types of reports and use cases. I'm also a bit wary of time, and that's why I'll stop there. But hopefully, I've done justice in terms of responding to that question.
Sure. Definitely, that answered my question. Thank you so much, Nik, for coming to Chaos Carnival and delivering this beautiful session. Thank you so much.
It's a pleasure. Thanks for having me. Cheers. So I can just hop out, Sarita?
Yes. Yeah.
Beautiful. Thank you.